So we've looked at how to express single gates in expressions like A or B or D and G, that kind of stuff. Now let's look at actually combining logic and Boolean expressions together. So for this one, how would I come out with a Boolean expression for this thing? So, and you've got A and B going into an AND gate. Remember now, I'll put a little dot here. AND gates are multiplication, and an OR gate is addition. So let's do this one. We've got A and B, so we can do the dot, or we can just do them right next to each other, A, B. And if you want to stick them in parentheses, that's great. Until you get kind of used to how things are stuck together, it would be an excellent idea to just stick things in parentheses every time they come out of a gate. The next one is CD, so that's C and D. Put those in parentheses. And then this line right here is getting ORed with this line. So what is this line? Well, that line is A and B. So A, B, and that's getting ORed with this line, which is C and D. C, D. Just like that. So that's our final output. That's our Boolean expression for this particular gate. So going from a Boolean, to go from logic gates to Boolean expression, that's how you do it. Just go each gate at a time, keep parentheses around them, just kind of keep them stuck together, married together, and then work your way down. Do the outputs of each gate, and then slowly go to the output, and you'll end up with a final output for your gates. Let's do another one. This one, remember, OR gate is kind of pointed, so it's an OR, plus signs, and this is a D shape, so it's an AND gate, which is multiplication. So again, in parentheses, we've got A and B going through there, so it's A or B. This one is parentheses, C or D. And then on the final output right here, we just got this line ANDed with this line. So we've got A or B ANDed with, and I could have put a dot in the middle or just put them next to each other. It's the same thing. Remember, multiplication, you can have just the terms next to each other. So we've got A or B ANDed with C or D, which is coming from the bottom line. So again, work the outputs of each individual gates, and those feed another gate. If we had more gates tied to this, they would feed into other gates, and we'll look at bigger ones here in a little bit. So a step at a time. Just do one gate at a time. If you mess up, if you think you messed up, just make sure double check those gates. You don't lose anything, don't add anything after you go through each gate. Just right as the gate comes out. So this one, let's do the logic gate to Boolean expression, but let's also do a truth table for this one. We've got plus here because those are OR gates, and this is an AND gate. So this one is going to be, draw your parentheses, F or J. This one's going to be TU, and for right here, let me draw it up here, it's going to be F or J or TU. So I got F or J right here, or this line is ORed with this line, TU. So F or J or TU. So giving you the truth table, and again, if you remember our 2 to the number of inputs we have, so this case would be 2 to the 4th, and you start with 0 and you go all the way up till, in this case they're all highs, so they're all 15. So you go from 0 to 15. So always make sure you end where they're all highs. You can also look at the pattern of ones and zeros we make. The least significant bit changes every time. So you got 0, always start with all zeros, and you got 0, 1, 0, 1, 0, 1, 0, 1. So every time it changes. The next one, it changes every 2 times. So you got 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. The next one you're going to change every 4 times. So you got 4 zeros, 4 ones, 4 zeros, 4 ones. And the next one you got 8 zeros, 8 ones. And guess what the next one would be? That's right, 16 zeros and 16 ones. So it would be 5 inputs is a huge truth table to work through. So what we do with this, and we'll go through the slides as we go, and I'll show you these laid out a little bit better, but in our truth table here, we're going to basically write down the outputs of each gate right here in the top of this truth table. And since I only have 3 gates, I want to go 3 outputs. So this first one is going to be F or J. Okay, that's the output of that first gate. The next one's going to be TU, And this last one, which I don't know if I have room for it, but I'll put F or J and TU. That's going to be the last box right there. So basically you have a box for each output. The only time that may be a little bit different, and even then it's not, is if you have inversions like bubbles, like NAND gates and NOR gates. It's easier to do the part before the inverter and then do a part after. We'll see an example of that in a little bit. So let me go to the next slide and I'll go ahead and have these in there to where you can see them a little bit better. All right, so for F or J, what we're doing is we're looking for F or J. We're ORing these two columns together, the two columns in green. And remember, for OR gates, we're looking for any high gives the high out. So we've got no highs in any of these, so you can see we're all low. Here we have a 1, so that makes our output a 1. Here we have a 1, which makes our output a 1. Here's a high, here's a high. You can see we pretty much have highs all the way down. So there we've got all highs all the way down for here. And let me do the TU one manually, and then I'll show you the nice output in just a second. So TU is actually ANDing these two columns together. Okay, you're ANDing. Remember, AND, you have to have all highs to get a high out on the output. So all highs on the input, that would be a 0. Well, we've got a 0 there, so that wouldn't work. We've got a 0 there, so that wouldn't work. Now we've got two highs, so that gives the high out. Remember, AND, all highs to get a high out. And we're just looking at these two columns. So there's two zeros, 0, 1, 1, 0. Now we've got two highs, gives the high. And two zeros, and a 0, and a 0. Two highs, and a 0, 0, 0. And now we got two highs on that one. So any zeros gives zeros, all highs gives the high out. Okay? And I'll go to the next one so you can kind of see what it looks like written out a little bit neater. And the ones in yellow I highlighted here, that's the columns that we're ANDing together. And for the last one, and again I'll do this manually so you can see it. In this one we're actually taking F or J and we're ORing it with TU. So I'm just going to put a plus here, but I'll show you here in a second the actual equation. So we're ORing these two columns together. So if you OR F or J and OR TU, any high gives the high out. So we've got 0 because we don't have any highs, no highs, no highs. There's a high, there's a high, high, high. So you can see we've got highs in all of these somewhere. Somewhere there's a high in all of these columns right here. And in these we have no highs, so it'd be just 0 out on the output. And that's all there is to it. You just go one at a time and then either AND or OR the terms together. And there's our actual final truth table as it should look. Work this one out and then we'll come back and we'll do we'll see how it works out. But pause it and then try this out on your own. Write you a Boolean expression for it and then come back and check your answer. Okay, here's the answer for it, and you can see the actual output, the final output is BG and P or L. And you notice I put a multiplication sign or a dot in there or not. Usually you see it this bottom way more often than you see dots in the middle of stuff. So that's the most common way of seeing it without the dot in there. Okay, here's some more practice. So pause the video, practice these, and play when you're ready to go on. Okay, here's the answers. And you can see the first one, we've got S or K going out of an OR gate. We've got S or V coming out of that OR gate, and that's getting ORed with W. So you get Y or K ORed with S or V. And you notice I keep things in parentheses just because it's a little easier to make sure you know exactly what gates are coming out of what. This one is G and M, M and F, and then we've got those going through an AND gate, so we've got G, M, and MF.